Welcome to Study Loop.
So here we need the for the angles of incidence and refraction to be equal. We need essentially the graph in figure 3347b. We need it to consist of a y equals x line at 45 degrees. However, this isn't the case. We have that the material one's curve here falls under the y equals x case, or y equals x line. So this essentially tells us that all refraction angles are less than incident angles, or we can say again simply theta sub 2 is going to be less than theta sub 1. And then using Snell's law, of refraction, we can then say that the refractive index of material 2 is going to be greater than the refractive index of material 1. So this would be our answer for part A. For part B, we know that we're going to use the same argument in part A. We're going to again use Snell's law. And if we're using Snell's law, then of course the refractive index of material 2 is also greater than that of water n sub 1. And then for part C, we know that we're going to examine the topmost point of the curve because it's simply easy to do so. So theta sub 2 is equaling 90 degrees. And then we can say theta sub 1 would simply be equal to 1/2 of 90 degrees. And then using Snell's law again, we know that n sub 2, the refractive index, is going to be equal to 1.33. This is for water, and this is found in table 33.1. And so using Snell's law, we find that the refractive index of the first material, n sub 1, would be equal to 1.9. This would be our answer for part C. For part D, we can say that similarly with theta sub 2 equals 90 degrees and theta sub 1 equaling 3/4 of 90 degrees and n sub 2 equaling again 1.33, we're going to use Snell's law to find that n sub 1 will be equal to 1.4, which is again still greater than n sub 2. This would be our answer for part D. That is the end of the solution. Thank you for watching.